today's session builds on that foundation. Rather than focusing on why we need it, today we'll see on how we do the integration, how we establish that connectivity to the providers, and integrate the applications from an enterprise deployment perspective. Okay. Now, moving ahead, this is what we saw in the last session, right? So now let's shift our focus from the gateway itself to the ecosystem around it. Now, as the AI adoption scales, organizations quickly realize that traffic management alone is not always enough, right? They need controls to protect the sensitive information around it, right? There might be some malicious interaction that would be happening with the AI models. So that's where we need to enforce governance, some sort of policies, and also make sure that the response that comes back from the backend AI is also compliant, right? Rather than building all of this capabilities natively into the NetScaler AI gateway, we take a integration first approach. Okay, the AI gateway itself act as a centralized enforcement point, like we saw the last time, right? So it allows the organization to connect specialized security, governance, and compliance solutions and plug it into the existing AI workflow. Now, this approach gives the customer the flexibility that they want, right? They can adopt the tools that best align with their security strategy while also maintaining the consistent control layer access across all the different applications and the providers that they use in the backend, right? Over the upcoming slides, we'll look at three different examples of the integration, right? And first, we'll start with Protecto, and we'll see how the sensitive data is preserved. Then we talk about Encrypt AI, where we cover the prompt injection and semantic threat detection. And finally, we'll talk about Azure content filtering, which is responsible for a safe and compliant response from the AI itself. Okay. Now, before we actually talk about the integration, just wanted to take a moment to talk how we actually do the integration, right? Now, the way that we integrate all these third-party solutions is that uh, we use something called as HTTP callout. Rather than adding it directly into the NetScaler like we spoke, we make the HTTP callout so that it is very modular integration, right? Traffic can be inspected by any of the external service, and it sends back a particular response on whether the request has to be allowed, blocked, masked, or any modification is needed. So this particular architecture is very vendor agnostic, right? So we follow a similar approach for all the three different integrations we have. So with this, the customers can integrate with the security and the governance platform that best fit their particular need and requirement, right? As day by day the AI usage is growing in all the different enterprises. Now, before they can adopt new services, they need to make sure that they don't make a lot of changes to the existing application, right? They don't want to go ahead and modify each and every apps. So that's where centrally you'll be able to integrate all these different third parties, right? Now, uh, with this, NetScaler continues to remain the enforcement point while the partners provide the specialized analysis capabilities. Okay, we'll start with the first one, which is about Protecto. Now, the first challenge that generally organization face is about protecting the sensitive information on what is being sent to the backend AI model. Right. Now, simply removing the data by matching a particular regex expression, right? Like what we do in traditional DLP techniques, will strip away the context of the user prompt. Now, uh, we can do that, but when that stripped away or masked request reaches the backend LLM, it won't be able to give you the same level of prompt, right? So that's where it reduces the overall quality of the AI response if we just go ahead and strip out directly. Now, let's take an example where a user sends this particular prompt, right? We highlighted what is that PII information that is available in the prompt. Now, the way that Protecto integrates is again with HTTP callouts. Now, when the request comes to the NetScaler, we perform a HTTP callout to Protecto, and that performs context-aware data classification and masking. Now, instead of removing the data completely, let's say the names, it changes it or it modifies it, right? So that it preserves the overall context in it. So it detects the entities and replace it with some meaningful placeholders. So the overall intent of the prompt and the structure is still in place. Now, on the response side, uh, let's say we send this the request to the LLM contains these particular identifiers, right? So it does not contain the actual PII info. Now, when the response comes back from the LLM, we convert these identifiers back to the original data, which we saw in the initial prompt, so that the end user sees no difference, right? As a result, now the organization can protect their sensitive data while also preserving the AI accuracy, and then the overall user experience is also not impacted, right? So just to summarize quickly, Protecto, you can think about it as protecting what goes into your backend AI model, right? Now, the second thing that I want to talk about is encrypt AI. Now, once the sensitive data is protected, the next challenge comes into how do you protect the backend AI itself, right? Attackers can try to manipulate by sending some prompt injection, jailbreaking prompts, or some prompts that are designed to bypass the controls that are there by default on the backend LLM. Right. Traditionally, if you see, we do a packet inspection on the payload. Uh, we can definitely match for some keywords, but we won't be able to match the context or understand the intent behind the prompts by just using the regexes, right? So that's where Encrypt AI comes in, right? It understands the intent, even though the prompt is in a natural language, right? So it applies the semantic analysis to identify if at all there's anything malicious or any uh, policy violating prompts before it is even sent to our backend LLM. Right? In this particular example, the user is trying to override the instructions that we have on the model to access some confidential data, right? And once the request goes to Encrypt AI, it assesses it and it gives a response that it detects a prompt injection attack, and then it informs to block that particular request. So with this, what happens? The NetScaler will drop this particular query and it will never send it to the backend LLM, right? So the way that encrypt AI is different from normal regex is that it understands that intent behind the overall prompt and not only look into the keywords. So it can look into some sophisticated prompts which might slip through the traditional controls that you might have. Now, uh, because of this, the result is that the responses that we get and the backend LLM itself is much safer and trustworthy, right? The overall interaction is protected. And if we take a moment and see, Protecto was protecting what goes into the AI. Now, Encrypt AI protects that particular interaction and the backend AI itself. Okay. Now, the third one that I want to talk about is the content filtering. Okay. Now, after the sensitive data is preserved, you're securing the backend AI. Now, the third part is what comes back from the AI. The responses that we get, are they safe? Are they compliant? Even legitimate users can unintentionally send something which might generate harmful, offensive, or some non-compliant outputs, right? So that's where the content filtering comes into place. It evaluates whatever the prompts and the generated responses are with the AI policies that we define, and it classifies all these across different safety categories. And accordingly, it filters and it decides whether the particular request has to be allowed, blocked, or any modification is needed. And accordingly, the response that is sent back to the user is modified. So now with this, we maintain that end-to-end user experience is safe. It improves the overall compliance and also reduces the operational risks that we might get, right? So just to summarize, Protecto was about what goes into the AI. Yeah, the encrypt AI protects the integration, the interaction that happens with the AI models, and the Azure content filtering protects what comes back out of the AI models. All right. Now, let's quickly see how this actually looks like. Okay. I'll let my colleague Landroy talk about it.
Hey guys, myself Landroy and I'm a consultant here at Citrix Asean. So let me start sharing my screen. Hopefully you guys are able to see my screen.
Yeah, good, Landroy.
Okay, so as we discussed about the different use cases and protection modules that we can use, I'm going to start with Protecto, which we talked at first. And we were talking about few use cases. Here are a few use cases that I'll be using. One is PI redaction when they're trying to generate an email. One is PI redaction for HR use cases where they're trying to write a prompt to gain some information from the LLM. So before we jump into the use cases, I would like to show how the configuration will look like. So we have segregated each protection module into different models. So you will see a different LBB server configured for Protecto. Now under that LBB server, how do we integrate Protecto is with the HTTP callout as we talked about. So there is a rewrite policy, which is an HTTP callout, as you can see here. So now what this does is, if you see the action under it, so it takes your complete HTTP request body that's coming in, which is your API call to LLM module. Now it will try to send that to the Protecto using an callout, and any masked value or changed value that comes back from Protecto, that will be served to your LLM module. I'll show you more on how this HTTP callout will look like, Protecto mask callout that is there. Similarly, we have an unmasking callout where we talked about keeping the context healthy and intact. So that happens by unmasking. So even that callout will look like the same. So we're going to take the response that is coming back from the backend. So we're going to take the content that is served by our LLM module, and we're going to send it to Protector to unmask it with an unmask callout, and we're going to replace whatever value that it provides to us from Protector. So, and then send it to the user. That's how we're going to do it. Now let's see how the callout will look like. So this is a Protector mask callout that's there. So this will send a specific backend for Protector, which is load balanced on our side. So you will see this is how the request will look like. This will be a put request where we send Protector auth header where we send the Protector's API keys, and we'll send the Protector mask body, which is our complete HTTP request body. So we send that body, and we're going to take the response that is coming back from that Protector's response, and then use that response body to you take the values out of it and send it to the LLM module. Similarly, if we talk about Protecto unmask callout, same. It is also a put request sent to our load balanced Protecto service, and it will have a Protecto auth header which carries the API key, and also it carries the content that is coming back from the backend LLM module. So this is how the configuration will look like. So every time a request comes in, we are going to send it to the Protecto security that we have. And then whatever response that it sends back to us, we're going to utilize that to send the request maybe to the user or maybe to the LLM module. So I'm going to run one of the prompt that we had. This is the same prompt that we had running in our PPT that was presented. So we are trying to generate an email. So we are saying I'm John, where John is a user's name, and write an email to Alex. Alex is also a person who is trying to write it to, and Boston is a city. So what our expectation is, instead of sending these John, Alex, and Boston values to LLM module, these should be masked. So on the left side, we have logged this, how this communication will look like. You'll be able to see how the masking and unmasking will look like. So here you will see the API request that is coming in. This is the complete request body, how it will look like whenever it's reaching the NetScaler. So you will see it sends the model name, the specific request that I had sent. I am John. Write an email to Alex about investment. You do see that here. And then what we're going to do is we're going to take this request and send it to Protecto for masking. So this is how the request will look like. You send mask as the JSON tag, and then you send the value inside it as the complete your HTTP request. You will see this I'm John value going in that request. Now, here is how the response from the Protecto will look like. So first you will see the value that you send to Protecto till here under the till value token completes. So you will see from here till here is what your prompt that you send to Protecto. And from here is the response from Protecto telling you how the request to your LLM should look like. So you can see here, instead of having user's name, it will mark to a random value with person tag added to it, similarly person tag, and city tag wherever a city was mentioned. So instead of sending complete username or the person's name and city name, it was a tag that was sent to the LLM module. Now let's see how the LLM will respond back. So this is a response that came from LLM module whenever we send the request. And we do see these tags are kept intact. So you can see the tags are still as it is, and it's responding back similar way. So it's saying subject is this one, and dear, the place, the person's name. So similarly, it answered back with a response. So now the same response is taken by NetScaler using the HTTP callout. There is an unmasked request sent now. Previously, it was a mask request, as you can see here. Now it is unmasked request. So the same detail is sent. You can see city details and person tag and city tag all are kept intact and sent to the Protector module. Now what we'll see is we'll see the real value again transform back. So it took that masked value and then provided you with an unmasked value as seen here. So wherever that city tag was there, it tagged the right city name, which was Boston. And wherever person tag was there for this 1H6 value, P value, there it utilized Alex value. And wherever there was N2P3KA value, there it utilized the other person's name value that was there. So this is how masking and unmasking will look like. This is one of the use cases that we talked about in the PPT that was presented. Now I'll try to show the similar prompt with another one. So let's say an HR is trying to create an event where he's trying to see ideas for a game. So this is how the LLM response is looking like. You can see the username, email is still intact when you see the response coming back from the LLM module. But now let's see what really happened in this communication. Let's follow the same approach. First, we'll see how the request came and landed to the NetScaler. This is how it looked like. Can you give me ideas? It does see the username and the email address that is shared. And if we see how the request was sent for masking, we took the complete body again and sent it to the Protecto module. And what did Protecto do again? It took that value that we sent, that is shown here, and then masked it with this value. This is the masked response that is coming back. You can see wherever there is email, it tagged it as email. Wherever there was a person, it tagged it as person. And then this masked response is then sent to the LLM module. Accordingly, the LLM module will respond back to us with the same details. You can see LLM module is keeping those tags in place, the person tag and the wherever there is need for email tag, it will also keep the email tag in place. Now let's see how the unmasking looks like. So we take the response back coming back from the LLM module again. This complete response is sent to our Protecto module, and Protecto again unmasks it. As you can see here, email is tagged back to the email value and username is tagged back to the username value. That's why even though there was a masking and unmasking process involved in this complete flow, you still saw the correct response with context intact whenever this communication went through. So now why this communication context is very important. What happens is whenever you send a next where prompt, let's say, give me more ideas. So now this complete request detail is sent in that prompt, and this will stay intact with username and email address still intact without breaking this communication. So this helps LLM module keep the complete context intact, understanding what it responded back previously and how it should respond back to this new prompt that is coming in. So this is how Protecto will look like. Similarly, for Encrypt AI.
Thanks, Lanway. So before we go with the Encrypt AI, the one point that I wanted to reiterate is that even though the user is entering some PII data, we see that PII data is not actually reaching the backend AI model over here, right? It's only the placeholders or the tokenized information is what goes to the AI. So now, even though user by mistake is doing all of this, you're still protecting your end-to-end traffic and not sharing anything sensitive outside of the organization. Thank you. Let's go ahead.
Yeah. Correct. So whatever that was explained, this is one of the use cases that I wanted to showcase where HR is trying to gain some game ideas. As you can see, email should not have been placed and username should not have been placed. Just the age information was enough to come back with the game details. So here, Protector understood that these are personal information and it masked it. So as per the explanation, this is how it will look like. So similarly, there is encrypt AI use case. So here are a few of the use case that I'll be covering. So instead of showing the masking and unmasking flow that I showed in this use case, what I will do is I'll try to show you side by side without any protection in place, without any guardrails, how AI will work like, and with guardrails, how the AI will work like. But before we run into the use cases, I'll try to show you how the configuration will look like. Similar to this Protecto configuration, there is also different LB configured on our side for this module called as encrypt AI. So when we check the configuration, here instead of configuring this with a rewrite policy, we will configure it with a responder policy. So this is the call out that's there. So what it does is it checks whether your request is good or to be sent to the LLM module or not. If it is not good, then it will be blocked. So the callout name is encrypt AI callout new. Let's try to see how the callout will look like. So, so instead of a put request that we saw in the protector module, here it is a post request. So we will, instead of using the expression based approach, we are using attribute based approach because attribute based approach supports a post request. So we are sending in the request host name of our backend entity, which is sitting on the cloud, and then the URL where we want to send this request to. And this body expression, what this contains is your prompt that is coming in. So it checks all the prompts that are coming in, and then according to the prompt, it will respond back with different values for your different placeholders that are there. So such as if there is PII, we'll check if PII value is detected, then it will be blocked. Or if there is an injection attack that is seen, then it will be blocked. Those result expression will be part of this configuration. Along with this, we will send header value content type application JSON and also an API key to the encrypt entity that's there. So this is how the configuration will look like. Now let's see with protected and unprotected AI, how it will look like. So I have a plain AI guardrail here without any AI guardrail. So here, let's start an encrypt AI communication. So I'll run this attack side by side with this prompt, and let's see how the responses will look like. So let's start with an injection attack. So here we are trying to do an injection attack. So on the left side, this is directly to our AI module. You can see the module responded back saying, I can't help design a virus because type of value is disabled for us. And the right side, request were went in. One sec. Give me one sec.
So while we're waiting for Android to come back, maybe if you guys have any open questions, you can just drop it in the chat. Okay, so that's a good question about license. So now, when we talk about the different integrations, uh, anything that you have on the NetScaler is included with the NetScaler license. But yes, if we talk about the third parties, the Protecto and AI and the Azure content filtering, all these are separate. So that is not part of the NetScaler license. Because in the end, all of these have to be different HTTP or the API calls that we make, right? And depending on the number of calls and the user prompt length, the usage will vary. the tokens are dependent on the prompt length, etc. We don't actually count the only the user request and response. So accordingly, you'll have to size the third party usage as well.
I'll try to show similar use case. One sec. Okay. So let's take injection attack. Sorry. One sec. Try to use the correct guardrail one. So you'll see it will detect that injection attack and then block it. So similarly, in the left side, you will see this went to the LLM module, and it clearly mentioned that it got this prompt, and it is not going to do whatever that is required, because even on the LLM side, they'll have whatever the production that is required in place. But if in sometimes if there is nothing that is in place, then the protection of that LLM module is compromised. This is one of the injection attack use cases. Let's see about PII value I'll send, which is not acceptable. So let's do the same thing. So same prompt on both sides. On the left side, you saw the value went in, and on the right side, it was masked. Similarly, let's take PII blocking attack. So here in this case, let's go with policy violation for PIA. So, and if you see on the right side, it was able to block that request because of PII being detected. So whenever it detects some value that should not be sent to the LLM, what we are doing on the encrypt AI side is we are going to block that request and tell the user that it cannot be continued further. We'll not let the user continue the conversation further because the context of that specific communication is now having not a prompt that should not be allowed. So if we do continue to allow that specific communication, then it's bad for the LLM module. So what the user has to do is whenever these type of issues might come, then they need to open a new chat and run a new prompt to continue further. So whenever we see a violation that is respect to jailbreak scenario, whenever we see a violation that is respect to PII value seen, and let's say there is an attack that is intent analysis involved, where we see a specific intent by the user. In all these use cases, what we're going to do is we're going to block this request before this request reaches the LLM module. So this is what I had to show about Encrypt AI and Protecto. I'll stop sharing my screen and let Shiva take over. Thank you, guys.
Thanks for that, Lanvai. So here we saw how depending on what information is there in the end user prompt, the semantic threat model is triggered and the analysis happens about what exactly is in the prompt. We don't only check for the keywords, right? We actually look for the intent behind the prompt. And that's where we could see that the encrypt AI request and the response clearly comes back with a threshold number. And based on that, we decide whether the uh, request has to be allowed or denied. And now the main reason of using AI Gateway is that it can act as your centralized enforcement or centralized control plane, right? So now, if you already have some apps connecting to ChatGPT or Copilot, uh, you have to change that to connect to the AI gateway, and on the back end, NetScaler will connect to your existing ChatGPT or Copilot, and they can continue to see the existing interface or the user experience will not change. but still you'll be able to enforce controls on your AI traffic. Any other question, guys? All right, I don't see any other questions. Now, even if we talk about AI agent, what exactly are we trying to enforce over here? Again, as we spoke, right, there are three different perspectives to look into it. One is about what the user is actually entering into the AI. Second is about how you can actually protect your AI itself. And third one is about how you are protecting the user from the response that comes back from the AI. Now, with NetScaler, you will be able to enforce or control all the three items, irrespective of whatever agent you are or whatever app you are using. We just have to change the endpoint or the LLM that it connects to and route it through the NetScaler. So in this particular case, customer is using Netscope, and Netscope by default communicates to some predefined Gen AI models, is it? Okay. So I think in that case, we need to include NetScaler AI Gateway within that path such that when the traffic goes out from the end user to Netscope, Netscope should send it to the AI Gateway instead of sending it to ChatGPT or the current Gen AI model that they're using. So that's how NetScaler will be able to implement or control. I think we're right on time. Are there any other question? Actually, this free version of yes. So the way that NetScaler AI gateway function is, we're very vendor agnostic. Okay, we don't look into what kind of LLM model you're using. Now, you should be able to integrate it, irrespective of it is OpenAI, the free version, or a paid version, a premium version. It does not matter. In the end, the API calls would look similar, and we will be able to implement the same controls. Now, if we talk about hotspot, then again, we're talking about the AI traffic coming only from trusted endpoints or trusted network. So that's where we can apply authentication and authorization for this particular AI traffic. So with that, you will be able to control that only traffic from the internal network or trusted segment is allowed, and if they're connected to their mobile hotspot, it's coming externally, you can go ahead and drop it. So we do have the controls in place. If there's no further questions, I think definitely what I would say, Amal, please reach out to the PSMs. I think Emang should be able to help for you so that he can facilitate the access for you guys and you'll be able to do it. All right, guys. In that case, thanks a lot for joining today's session and looking forward to the upcoming sessions, and please do share it with your colleagues and others as well. Thank you.